chapter 12, Math 92. I put a copy of this on Canvas already, so I would suggest that you print a copy of this while you're watching this video. Now, this chapter mainly is talking about, they call it exponential functions. And for that, before I go over these, let me explain this to you. You know, let's say we want to graph functions like this, y equal x to power of 2. To graph any functions, one method is you just come up with some arbitrary numbers. You just come up with some positive, negative numbers and also 0, and you take all these numbers and substitute for x to find your y value. For instance, if I take the 0 and substitute here, 0 to power of 2 is 0, so the first point is 0, 0, which is here. And then x1, 1, and so on. When you graph it, you see half a bowl or a parabola, okay? Now, all the functions like y equal x2, y equal x3, y equal x4, they all have base is the variable and power is the number. Now, in chapter 12, there is the new function, they call it exponential functions. These functions, base is the number and exponent is the variables. It's completely opposite. See again here. Here you have base. Base is variable is x. Exponent is the number. But for exponential functions, it's completely opposite. So I had x to power of 2. Now here I have 2 to power of x. Again, like any other graph, you always have to come up with some numbers. I'll come up with some arbitrary positive, negative, and 0. In this case, it doesn't matter whether x is 0, positive number, or negative. You always come up with a positive value of y. So you see this type of graph is always above x-axis, or y is always positive in it. And when a number is positive and keep increasing, the value of y increase. But when the number is negative, the y decrease. And the reason is this: you need to remember we had a formula that if you have a positive number or negative, if you have a negative number as an exponent, you always change it to the positive by reversing it. See, let's look at this example. 2 to power of 1 is 2. 2 to power of 2 is 4. 2 to power of 3 is 8. And of course, 2 to power of 0 is 1, just the definitions. What is 2 to power of negative 1? See, when you have 2 to power of 3, this exponent indicates that we are taking 2 and multiply by itself 3 times. Or here, 2 means you take the base, which is 2, and multiply by itself 2 times. But when you have negative 1, how could I take the number and multiply negative times? It's meaningless. So in that case, I use this formula that if you have a negative exponent and you want to change it to the positive, reverse it, put it at the, like here, if it's a denominator, bring it to the denominator. So in that case, 2 to power of negative 1, remember some student by mistake, they think this is negative 2. No. 2 to power of -1 is 1 over 2, which is 0.5. See, it's a very small number, or at least is less than 1. Like, what is 2 to power of -3? I cannot take the number and multiply by itself negative times, so I have to switch that to the positive, which is 1 over 2 to power of 3, or 1 over 8, and 1 over 8 is the decimal number. It's 0.125. So we are using this formula in this chapter. And here, when x is keep increasing, 0, 1, 2, see the y value increase. But when you're dealing with a negative, you see the number, the y value decrease. Anyway, so this is how the exponential function looks like. So it could go either like this, or it could go like that. Okay? All right. So now let's go back to that problem here. So this type of functions, they all have exponent as a variable. Like here is, the answer is 40 multiply 3 to power of h. See, exponent is the variables. And the way we came up with the formula is, they are saying here is, this bacteria triple every hour. After 1 hour, if you start with 40, see, they start with, if the sample of 40 bacteria, means we start with 40 bacteria, right? If you have 40 bacteria, after 1 hour, it triple, means it's 120. What happened after 2 hours, means 1 more hour, you're gonna triple again. Means you have 120, if the time passed 1 more hour, this 120, you triple again. And again, what happened after 3 hours, means you, after 1 more hour, and it's like this. So if you keep doing that, you understand that eventually, see here, 3 is to power of 2, 3 to power of 3. So finally, it's 3 to power of n or h or whatever. That's how we came up with the formula. And then when you have the formula, and then they're asking you, what happened after 9 hours? Basically, all it means, put a 9 here for the power. Use your calculator and find 3 to power of 9 and multiply by that. What happened after 11 hours? Use your calculator and put 11 for h, 3 to power of 11 times 40. Part D is different. Part D, they give you what you have on this side, and they want you to find the h value. This one is a little bit different with the other problem that you see, because you need to do some kind of calculations here to find it. So I have, let me write it here for you so you could see it better. You have something like this. First, I divide both sides by 40. So 1 million divided by 40 is 25,000. So we can kind of estimate the value of n or h, I should say. Doesn't matter. What number shall I plug in for h in order to take 3 and raise it to that number is 25,000? It's not that easy, you know, but if you want to find a rough number, you just keep saying, okay, h is 1, h is 2, h is 3, 4, 5, 6, 7, 8, 9, till you find a number close to that. But we don't want to go to very details in log problems here, but one way to do it is you put a log or log on each side. One of the property of log is that you could always bring the power to the front. What log does, it solves the exponential equation. Exponential equation is an equation that exponent is a variable, right? So h log of 3 is log of 25,000, and then divide both sides by log of 3 because we want to find h value. So h is log of 25,000 divided by log of 3. Okay, and then I need to find log of 25,000 divided by log of 3. Even the basic calculator would have it. You don't have to have this fancy one. In my calculator, let's see, the log is here, log. You see that? Log. Then you say log of 25,000, close the parentheses, divided by log of 3. It gives you 9.22. Okay, I'll do it again. Look, let's clear this. You want to find log of this divided by log of that. There is a log here. Log of 25,000 divided by log of 3 is 9.2 or 9.21. You could always pause this and copy if you want to understand it better. Okay, so that's what we have for the first problems. Now, on this one, on this problem, they are saying that every 210 minutes, 21 triples. You have this number, 21 bacteria, and every 210 minutes, it would triple. So look, in the first 210 minutes, it would, 21 is, it's not the triple, is it? Oh, no, I'm sorry, it's quadruple. Quadruple instead of triple. So in the first 210 minutes, 21 times 4. What happened after additional 210 minutes? Or what happened after 420 minutes? Or after 2 hours? Again, you just take that and multiply by 4 again. What happened after 3 times 210 minutes? So the formula is 21 times 4 to the power of n. And then B is what happened after 7 hours. Seven hours means what? 420 minutes. And then that 420 minutes is about is about 2. So you take that number and you put it here. That would give you this 336 minutes. Say this is exponential function. Remember I showed you something like this here before? Like this or like that. So on this one, first of all, is this increasing or decreasing? Obviously it's decreasing, right? It's sliding down. Let's say if you drop somebody here on the slide, ooh, go down. So it's decreasing. Is it exponential growth or exponential decay? Is exponential decay. Why? Because let me show you here. Let's look at these two problems. These are two separate functions. In the first one, or let's just, instead of that, let's just write this one. Said 0.5 to power of x. In this one, when x is 1, y is 2. When x is like 3, y is 8. When x is 4, y is 16. See, when x increase, so does y also increase. So x increase, you keep giving a higher number to x, and y also increase, okay? This is increasing functions because they both are increased together, direct relations. But look at this one. X is 1, y is 0.5. X is 2. What is 0.5 to power of 2? It's 0.25, right? What is x equal 4? 0.5 to power of 4. 0.06. What's happening is x is increasing. See, 1, 2, 4. X goes from 1 to 4, but y decrease. One is going up, the other one is going down. What's the difference between these two? This is decreasing function, this is increasing function. In decreasing function, the base, this is the base. So if this is a general equations, a is less than 1. But here, a is greater than 1 or 1. So that's a sign of increasing function. This is a sign of decreasing functions. Okay. So if one goes up, one variable goes up, the other one goes down, means decrease. If one variable rise and the other one also rise, it's increasing function. So if that's the case here, look, let's say here, this point, x is 2, y is 10, right here. This point, x is 2, y is 10, okay? Now let's look at like this point. Let's call it point A and B so we see it better. Point A, x is 2, y is 10. Point B, x is 1, but y is 20. See, they're completely opposite. One is going down, the other one is going up. This is a sign of decreasing function. As long as these two are opposite, either this goes up, the other one goes down, or vice versa, it doesn't matter. But they are not following each other. They don't go in the same direction. So this is decreasing functions. Okay? One goes down, the other one goes up. They call it exponential decay. So let's go back to that one here. So if that's the case, if you have a situation like this, then one goes up, the other one goes out, or decreasing function, this is, they call it exponential decay. And this is growth. So all the increasing function are exponential growth, and all the decreasing functions are exponential decay. So you got to remember that one. All right. So then this one is what? Is exponential decay. Why? Because when one goes down, the other one goes up. So they're completely opposite. Now, what does f of 1 means? You know, in algebra, when we give you equations like this, look. We get a new paper. In algebra, when you have equations like y equal x plus 1, y and f of x are the same thing. So sometimes instead of y equal x plus 1, you could write f of x equal x plus 1. F of x and y are the same thing. All f of x means is there is a function that has a letter of x. Like, what's the difference between this one and this one? Look, g of a equal a plus 5. G of a means just y. The reason instead of y we write g of a, to just tell you there is a function with letter of a. That's all it means. So f of x, g of x, or I don't know, d of m is like m plus 3, right? Okay, so these two are the same thing. When I say this one, when I write x equal 3, how do I find the y value? You take this 3 and substitute here, right? So it would be 3 plus 1 is 4. The same thing here. When we say find f of 3, find f of 3 means x is 3. So take this 3 and substitute for x. So f of 3 means this. Take 3 and plug in for x. It's the same thing again. You see that? So f of 3 means x is 3, find the y value. What does f of 7 means? Means x is 7. What is the y value? Take the 7 and substitute here is 8. Okay? So that here, they're saying what is f of 1 means? F of 1 means x equal 1, find the y value. So you go on the x-axis and find 1. If you want to find the y, draw the vertical line, they hit the graph, and then that'll read the 2. Okay? Like here. When we say x equal 1 and find the y, or find f of 1, from here, from x equal 1, you go up to hit the graph, you draw the line, and then you go to the left. This is your y value, which in this case is 20. So when x is 1, what is the value of y? 20. And vice versa. Here they're saying f of x is 10. What does that mean? Find the x when f of x is 10. Find f of x when find x when f of x is 10. Right here. This one means find x when y is 10. f of x equal 10, remember f of x is y. Means when y is 10, what is x? So in that case, when we tell you that y is 10, find the x, this is the y value, right? Or the y-axis. Find the 10 here, and then draw the horizontal line here, and like that. This is the x that they're looking for, which in this case was what? Was 2. Okay? So when we give you a y value and ask you for x, you label y value on the y-axis, you draw a straight line to the right, and then down, that give you the x. If we give you the x and ask you to find the y, you find the x on the x-axis, x equal 1, you draw a vertical line up, left, to give you the y value. And that's what you have here. Estimate the y-intercept. Y-intercept is a place that you line with the y-axis. Like if I have a graph like this, and if there is a line goes like this line intersect the y at this point. They call this y-intercept. Y-intercept is the place that my straight line hit the y-axis. This point obviously doesn't have any x. See, x is always 0 on this one, but it does have a value of y. Like in this case, let's say y is like 7. This is an example. So y-intercept is 0 and 7. Show you another one. I have this graph, and this graph hit the y-axis at this point. They call this y-intercept. It doesn't have any x. X is 0. What is the y value? Is from here to here. Let's say is like 1. So they say y-intercept is that. So y-intercept is the place that, in this case, my graph hit the y-axis, and it doesn't have any x, but it does have a y. If I have a straight line and hit the graph, this is y-intercept. It doesn't have any x and has a y value 0. So here, they're telling you, find the y-intercept. I look, and I see this graph hit the y-axis right at this point. Right at this point. Read the coordinates of this, which was 40. Now next is we go to the next example. On the next example, we ask you first, is it increasing or decreasing? Obviously it's going up. You see, like, look, when x is 10, what is the value of y? 30. When x is 20, what is the value of y? 40. So when x is 10, y is almost 30, let's say 28. When x is 20, y is 40. So what happened is, look, x is increasing, y also is increasing. That is the sign of increasing functions and exponential growth. Remember, if you have a situation like that, that x is rising and y is rising, is increasing and growth. But if one goes up and goes down, is decreasing or exponential decay. All right, now here, what is f of minus 20? Remember, f of minus 20 means when x is minus 20, what is the y value? You find minus 20, you draw a vertical line to see where they hit the graph, you go to the right, fine. Find the x when y is 40. F of x 40 means y is 40. Remember, f of x is y. When y is 40, what is x? In this case, you go on the y-axis, you find the 40, you draw the line to the right and down, that gives you the x is 20. Find the y-intercept. This graph intersects the y at this point. What is coordinates of this point? 0 and 20. Now, these problems are also very similar. Like here, they give us some points and they ask us to come up with the equations. I see that I start with 13, right, for the y value, but then 52, when I take 52 and divide by 13, when I take 52 and divide that by 13, I came up with 4. So I can just write something like this: 13 times 4 to the power of 0. Why? 4 to the power of 0 is always 1 times 13. So if the 13 is first number, and then you have 52, that when I go from 13 to 52, what happened that the number changed from 13 to 52? You multiply that by 4. And then you go from 52 to 208. Take 208 and divide by 52. It gives you 16, which is 4 to the power of 2. So if I keep increasing the power, I come up with these numbers. So how do I come with the base? The base is the very first number. Look at this one. What's the first number? Minus 25. So that is your base. And how do I find this 5? Take these two and divide. 125 divided by 25 is 5. So that would determine number that you have in the parentheses. So 52 divided by 13 is 4. That's the number you put in the parentheses. 13 is the number you start with. You start with minus 25. When you divide these two numbers, it's 5. That's the number you put in the parentheses. And on this one, if I take 248 and 124, you go from 248 to 124. So something happened is see, the x is increasing, but what happened to the y is decreasing, right? So that means if I take 124 and divide that by 248, that gives me 0.5. See, this is a decreasing function because look, x going up, but y is decreasing. That means this is you have to find the a which is less than 1. Your base has to be less than 1, which is, it's 0.5. So again, remember, for these problems, 13 rise to 52. Then that means a was positive because it was increasing functions. So you take 52 and divide it by 13, right? Or here, you take minus 125. But here, when you go from 248 to 124, when you divide these two, it gives you 0.5. So that means the number in the parentheses is 0.5. Because this is a decreasing functions. Same thing. The very first number is what you start with. Okay? But look, x is increasing, but y drop. So you take 550 and divide that by 2200. That gives you 0.25. That's the number that you need in the parentheses. And you put it here. Okay. All right. Now, they're asking you a question. It said, determine whether the given exponential function is increasing or decreasing. Remember the a value, the base. What is the base? This is 6 to power of x. Base is 6. If the base, let me write it here so you could see it. If the base is greater than 1, function is increasing. This one is 0.1 to power of x. Base is less than 1, function decreasing. All right, so now here, this is exponential, how to solve exponential functions. Some of them is like this. 4 to power of x is 64, right? I'll show you first. If you want to break 64, you do it this way. 64 divided by 4 is 16 divided by 4. So 64, in fact, is 4 times 4 times 4, or 4 to power of 3. So instead of 64, you put 4 to power of 3. But look, these two. What number shall I put here? Obviously 3. What number should I put here to get 4 to power of 3? 3. One over 16. Remember this formula. If you have x to power of n is 1 over x to power of n. And when you have, I should put a negative here. So please correct that on the statement. I didn't realize that. All right, x to power of n is 1 over x to power of n, and vice versa. So if you have 1 over x to power of n, like here, 16 is 4 to power of 2, right? So this part is like this. If you have it at the denominator and you want to bring it to the numerator, then you just put a negative. So 4 to power of 2, to bring it to the negative, you come to the numerator like this. Look, x to power of negative n is 1 over x to power of n. Okay, I have 1 over, and what was it, 16? 4 to power of 2. According to this formula, you put a 4 here, right? Because your x is 4 and n is 2. And minus 2. So if you already have it at the denominator, you bring it to the numerator. Like if you have a denominator 1 here. X to power of n, or 4 to power of 2. If you want to bring it to the numerator, you have to change it to negative. Okay, so we use that here. So now you have 4 to power, let me write it here, 4 to power of negative 2 is 4 to power of t. See? So t is what? Negative 2. Same thing, look. 25 is 5 to power of 2. If you want to bring it to the numerator from the denominator, you have to write it as 5 to power of negative 2. Again, this one also is negative 2. What number shall I put here that when I take negative 5 and raise it to that is 25, 2? This one, 1 over 7. Remember, 1 over 7 is 7 to power of negative 1. I show it here. And then when you have more than 1 power, according, we had this formula at the beginning. If you have more than 1 power, you always multiply. So minus 1 times this is minus t. 7 minus t on this side, this changed to, and 49 is 7 to power of 2. So t is also negative 2. So we are applying 2 formula here. I show you two examples again. If the base, which is this number, is greater than 1, then the function is increasing and is growth. If the base, which is this number, is less than 1, which it is, the function is decreasing or decay. And I'll show you an example here. Look, let's say there is a city with population of 300,000, and we said there is 5% growth. What does that mean, 5% growth? It means you take these numbers, okay? You take that 300,000, you multiply that by 5%. 5% is 0.05. You do that. Whatever the number is, you add it to 300. So then you have 300,000 times 5%. It's 15,000. There is a growth of 15,000. And then you take that 15,000 and add it to 300,000, which is 315. You could either do that or just take 300,000 and multiply by 1.05. It gives you the same thing. In case of reductions, you always subtract from 1, okay? If I ask you to reduce it, then you take this 15,000 and subtract. So in case of reduction, it's always 1 minus. In case of 5% growth, is 1 plus 0.05. So you need to remember these two parts. When we say reduction, in the parentheses, you have 1 minus that percentage. When you say it's a growth, in the parentheses, you have 1 plus that, because you always increase it. And on this problem, 16, 17, 18, see, I show it here. This formula is given. They say what happened after 3 hours. Multiplied by 60 is 180 minutes, divided by 20 is 9. See, here. See, this is a formula, 45. But they're saying in this formula, Bn is number of bacteria after n 20 minutes. N 20 minutes, okay? So like, if you have the first 20 minutes, what happened in the first 20 minutes? It's 45 times 2 to the power of 1. What happened after second 20 minutes or 40 minutes? 45 times 2 to the power of 2. What happened after 60 minutes? 45 times 2 to the power of 3. And that's what you have here. So every 20 minutes, how many 20 minutes are in 180? 9. So that would be the power here, okay? So the first 20 minutes, n is 1. When you add another 20 minutes, or in the first 40 minutes, is 2. 60 minutes, 3. 180 minutes is what? 180 minutes? How many 20 are in 180 minutes? 9. So you put 9 here. Okay. See here it said, find the number 17, find the growth or decay rate. Look at the base is 1.09. What is it? 1.0 is greater than 1. So you know it's growth, it's not a decay, right? Decay, in the parentheses, you should have a number less than 1, but this is greater than 1. So it's a growth, we know that. How do I find this 9? Look, in the parentheses, you have 1.09, and you know is the growth. Why? Because 1.09 is greater than 1, right? Separate these to 1 plus 9% or 0.09. This is your percentage of the growth. Look at the number 18. What do you have in the parentheses? 5.75. 5.75 is greater than 1, right? So what is that? Growth. How do I find the percentage? 5.75, write it as 1 plus 4.75. So this is your growth. If you want to find a percentage, always move the decimal to the right 2 digits. So it's 475%. If you use your calculator and take 475 and then percent, or when divide by 100, that's what you get. So anytime they ask you to change the decimal to the percentage, you move the decimal 2 digits to the right, and vice versa. If it's a percent means what? What is 475%? Percent means take that number and divide by 100. So that would be 4.75. What does 9% means? Let's go back to this. 9% means take 9 and divide by 100, which is 0.09. See? 0.09. This is a convergence. If we tell you it's 0.09 and ask you to find a percentage, you move the decimal to the right 2 digits to find the percent. Now look, this one, in the parentheses, the base is less than 1. What is that? It's a decay or it's decreasing, right? If the base is less, in the case that base is less than 1, you use this 1 minus. This is in case of decay. 1 minus in case of growth is 1 plus, right? This is decay, so 0.95 is 1 minus 0.0. So this part is your decay or percentage. Number 20, same thing. Let me read number 20 for you first here. According to United Nations record, the world population 1975 was 4 billions, and find the population in PT is the world population in billions, and T is the time in years 1975. Find it in 2018. So originally this formula established in 1975. Now what happened in 2018? The difference of these two would give you the T value. See, 43 years. You take that 43 years and you put it here. And that gives you this number. According to this model, what is the growth rate? Why is the growth rate? Because look, in the parentheses, this is greater than 1, right? Remember, to find the growth rate, you take these and write it as 1 plus. So 0.019 is your growth. And if you want to change it to decimal, all you need to do is move this to the right 2 digits. So how we know is the growth? This number is greater than 1. And if they ask us to find the percentage, in case of the growth, we always write 1 plus that. All right, so that would be, I think, the last chapter of this term.